Hello, in today's video we're going to look at the final video I'm doing on sorting algorithms, and in this one I've made a small UI, a user interface that allows you to explore how these different algorithms work. So if we pick the bubble sort and then we drag this down to about 30 and we press play, you can see how the bubble sort process is working through each of these columns, slowly but surely sorting all of these rectangles. And if we go to quick sort and we can drag this up to, well, let's do a big one, let's do 200. We can pop it here and you can see how it's partitioning the data, splitting via that pivot point. And then as it slowly works through each of the lowers, we start to get some order. And this number of swaps up here can be really, really useful for working out, it can be really, really useful for working out how effective these algorithms are. So I think when I run this one with bubble sort, it takes about 8 to 10,000 swaps. Whereas when you do quick sort, and actually this one's taking quite a while, it took about 570 swaps. So much, much better. And then heap sort, well, we'll drop it back down to 100. We'll reset and press play. And of course you can pause this at any point during the flow to have a look at what's going on. And it's just a nice little program, and it's been made in Pygame to help explore sorts by just picking the the number of elements and the type of sort. And it's super easy to add another type of sort into this program. Here you can see how the tree is you're getting the max heap, and then it's just pushing the max heap into the sorted. There we go, 491, that's not so bad. Right, so what I wanted to do in this video is we're not going to go through a full code up because it would be quite long. But what I'm going to do is everything in this video is on GitHub, all of the files, and I'm going to walk you through the structure and a few of the key points within the program, so that if you want to go and play around with this, you can grab those files. And in fact, I think I did all of the coding through Git as well, so you can have a look at each stage as I made changes and some of the mistakes I made and some of the ways I solved a couple of problems. There are 3 key files. There is also a font file, which is this LCDU font. It's quite nice, I like it. It looks a bit like an old calculator screen. And there's also the image for the background, which is called Earth JPEG. And they're all in the GitHub repository, so you can grab those as well if you want them. So what we have is a super simple little program where we're using Pygame and random, and these two we create ourselves. Sort modules and nav modules. We've just got a function to tell us if a point's in a rectangle, and we've got a function to tell us if a point is in a circle. And we've used both of these on previous projects, so I won't go into much detail with them, but they're really, really easy. Effectively, with the circle, you're just looking if anything is within that distance, a Euclidean distance from the center of the circle, and if it's less than the radius, then of course the point is within the circle. And here's the Euclidean distance. I think we did this first in the KNN video, the KNN introduction. So if you want to find out how this guy works, that's where to go. So that's the nav modules. So we have to initialize Pygame. We do all the usual, setting a window width and a window height. And this play variable is used to switch it on or off. So basically to determine if the animation is running, so if we're having those rectangles moving, or if it's not. And certain things can be allowed, like you can press pause when it's running, but you can't change any settings while it's running. And the mouse sticky, that is only for the little slider, and we'll see how that works in a moment. We initialize the whole thing with elements set to 100 and the choice as bubble sort. And then we have initializing the sort object, and this is where we use a sort class which comes from here, and we'll have a look in our sort class in a moment, and that manages actually all the complexity of getting the frames that we then show as our animation. And we just use random to initialize an array, and the array is of length or elements. So you can select the number of elements you have, and then we just have our loop, our sort of game loop for Pygame, but the while true, and then we run through here, and this is just to allow you to exit, but all of this is selecting a user input. So if the event button is 1, so you're pressing the mouse button, I think it's the left hand button, and play is equal to false, you can change the selection of the sorts to bubble, quick or heap, and you can also do things like move the slider to get the different number of elements, and you can press play, and you can also reset, and reset is also a way of kind of reshuffling, so you can get a different array. But if the play is equal to true, then all you can do is press the pause button, and that will of course pause it, set play equal to false, and away we go. And that's to do with the slider. So the slider, it's not an imported widget or anything like that, it's just a circle on a line, and you move the circle dependent on the x-axis of the mouse position. So it's a really, really simple little implementation, but I think it looks quite nice. And then what we have is displaying the blocks here. In fact, I'm just going to open this up full. In this section here, so in all of this, we're basically using the window width to limit the width of each of those rectangles. And then we're taking something called a frame from our sort object, from that class that we've created. And that's because actually how this program runs is it doesn't show you the sort as it's progressing. It completes the whole sort in milliseconds, and then creates a bunch of frames from arrays that were stored during that sort. And then it just shows you those arrays at, I think it's 15 frames a second. And so that's how we control the speed of that change. And we're just using Pygame rectangle to draw the rectangle, because we're iterating through this array, this frame, and we're using count to work our way through each frame. And then whenever you press reset, count goes back to 0. When you press pause, it doesn't, and that's how you can start playing and pausing, and you can come back to something. This is for the dynamic text. So for the elements, the number of elements shown as a number, well, that's super easy. We just have elements and this little F string, and we can then use the normal Pygame text features to show that. This was a bit interesting because I wanted the swaps number to have leading zeros if it wasn't up, well, it wasn't into the 10,000s. And so I found this really, really neat little feature of F strings, and I can't remember who did it, but I'm going to put a link in the description because he's got some fantastic content with little tricks and tips to do with Python, and I find them very, very useful. Anyway, this was just showing the count value, but what it does is if the count value doesn't have more than 5 digits, it leads it with up to 5 zeros. And that creates that little effect in the top corner. And then down here we've just got displaying all of this text to the screen. And then we have the typical display update and the clock down here. So that's the main file. Everything's pretty self-explanatory, with just managing most of the display work really. And then the brains goes on inside the sort class. And in this sort class, we initialize an array, and that's our random array at the beginning. We have a choice, and that's whether it's the bubble sort, the quick sort, or the heap sort. And we have a status, and that's just whether the object is sorted or not. If it's not sorted, it's false. If it is sorted, it's true. And we have frames. It's very important that in frames, everything is a copy, because otherwise you end up just updating a bunch of duplicates of the array. And then item log, and this is one of the bits in the code I'm least happy with, but it's effectively just a bin for values that you might need in one of the sorting algorithms, and that's really important actually for quick sort, and we'll get into details of that later. And then we have just a simple function to run the sort, and that's because if it's not sorted, when you want to come and animate it, then you run the sort first, and then you go to the animation. And it just takes the choice, so if it's bubble, it runs the bubble sort, quick runs the quick sort, and heap runs the heap sort, and then changes the status to true. Now the bubble sort's super easy, and all of these sorting algorithms are covered in previous videos. I've got a playlist of them now, so if you want explicit details of these sorts, have a look at those videos. But the bubble sort's super easy. You just have loads of comparisons going along as you iterate through each list. And every time something swapped, I would take a snapshot. So self.frames would append a copy of the array after this change had happened. So you were building up this great big array of arrays called frames, and each array was effectively like an image in a video, except it was just that list of numbers moved around. And so that's how we animate the bubble sort. We'll come back to quick sort because it was a headache. Heap sort was super easy. Again, instead of just doing it within one though, we did it within the tidy heap. So every time you did a tidy heap and you would have a swap go on here, again, you would have the heap appended to frames. But you couldn't just have the heap because the heap was decreasing in size, so you'd start to lose rectangles in your animation. You had to add the sort array as numbers were being sorted, which is why you get that kind of ordered list on one side as the max heap root is constantly being moved over to the sort. But I thought it looked really cool anyway, so we'll stick with that. But you have to be careful as well because it won't do the last one here. When heap is empty, the sort array is full, but you don't run a tidy heap on a heap that's of length 0. So you have to add in this final one here in the heap sort frames, which will add the last image of the array that's all nice and tidily sorted now. So now we'll have a quick look at quicksort. Now this was a headache because it's recursive, and effectively it's really hard to pull out those values as they're being sorted to give you an array in the way that we've done for bubble and quicksort. So what I did is cheat a bit. I ran the quicksort algorithm and I logged the pivots. That was all I took from it, just the pivots, so that I could see what pivots were required to get the array sorted fully. But then what I did, and also the order of the pivots, that's quite important, sorry. But then what I did, so we ran the quicksort here, and now we've got that pivot lot stored in our log, our item log. And then for pivot in the item log, what I did was I started creating frames by effectively just moving everything according to the pivot. So if things were already sorted, if they were already lower than the pivot, they wouldn't move, so you didn't get a new frame. But if they were greater than, or if they were below the pivot and they needed to go above the pivot in the frame, they would move. So you actually ended up with a visualization that was just like what the quicksort was doing, but you were able to see it frame by frame and do it in this linear fashion. But it does work really nicely, and you get that really clear visualization, seeing chunks moving around to either side of the pivot as things are sorted. And that's the whole program. It's just these 3 files, an image file and a font file, to give a really, really nice little UI to experiment and explore. And I hope you like it, and I hope you play around with it a bit. I particularly like watching the quick sort as it goes. I think it's really quite fun, and you can see it as the items are shifted around. There we go, it's not taking too long. And you can also see that heap sort is very close to quick sort. Sometimes it's way off as well, but in nearly all cases quick sort is faster, and that's why of course it's preferred. Anyway, I hope you've enjoyed this video. If you want to tinker with this piece of code, or you want to just use this UI for learning or for exploring these sorts, please feel free, and I hope you enjoyed. If you do like this video, don't forget to like and comment, and if you like this kind of content, why not subscribe? Thank you so much for watching, and I'll see you in the next one. Bye!